This video is the second part of a two-part series on RBD tools, tearing and deforming metal. In this video, we'll start to tweak the soft constraints on the metal panel that was set up in the scene from a previous video, which is the first part of this series. Please check out that video. Links in the description. In the RBD bullet solver, there is also a breaking thresholds tab. So what this will do, now it will break these constraint names when they have moved this certain distance. So don't be confused with this and the glue strength. Now the glue strength, how strong it is bonding to nearby pieces. That piece has moved a certain distance away from its nearby pieces. I mean, the glue can still be partially bonded, especially if it's a soft constraint or a spring constraint. So you can, if you've seen a previous video of mine, pieces can spring back and forth together. This will actually break the constraint to completely. Well, you have a choice to delete the constraint or switch. This is super interesting, which I'm just gonna go over in just a second after I finish explaining the delete constraints. So this gives it a certain distance threshold. So if this would be more useful if it's a spring constraint, or in this case, a soft constraint. If that piece has moved apart from its neighbors above this threshold, above this one Houdini unit, then it will completely delete the constraint. That means that broke. So the spring is sort of like the spring that the ball hits that wall spring hard enough. The pieces start to spring far enough that it will break. You can set this to a very high distance if you want the spring constraints or the bond to be super strong or strong enough through a distance. Now this brings me into switch to next constraint, which is what we will need in order to get this metal tearing effect. Let's go back up here. So we can use this constraint tab and just enable it right here. Switch to soft constraint when broken. So this is awesome. So once the glue constraint breaks, it will automatically turn the glue constraints into a soft constraint. It will automatically turn all those. So once you enable that, all glue constraints will turn into soft constraints at a certain threshold once this breaks. So after enabling this, let's give this a try. Now, in order to visualize it, go to the RBD bullet solver, come to the visualize, come over here. Constraints, constraint name. Let's turn this here. So right now is all the glue constraints. Let's play it. You can see that it sort of acts like a wormhole, sort of absorbs it, and it kind of comes back. So you can see a sort of spring effect, closing it back in. Now that's pretty cool. So after this breaks apart, it starts to close back up with the springs back in. However, that's not what we want. So let's come over here to the bullet solver. Why is it doing that? Is because the soft constraints are way too strong. So the soft constraints aren't breaking at all. Let's lower this distance. So I do want it to break a lot easier. So let's try 0.2. Oops, let's replay. So that's a bit better. That's a bit better. At least we have a hole now. But I still want it to break even more. 0.1. Let's try it again. So that's getting better. That's getting better. However, this is unsightly. If you can see this, this is like a piece of puzzle kind of springing back in. Now, I don't want that. The reason why it's like these pieces that have turned into soft constraints are parallel to this. So these pieces are parallel to the metal plate. They're not breaking off the way that I wanted to. Now that can be fixed with another RBD constraint node. Constraint. Now there's something, these ones, the first four are RBD Constraint properties, RBD constraint curves, lines, rules. Now I'm just gonna, we're not gonna be using this one, but I feel like I need to go over this one. The one that I really need is this RBD Convert Constraints. But before I get into that, I'm just gonna slightly go over this one, constraint properties. So let's put this down. So what this does, this will look very similar to what the RBD material fracture constraint tab. So what this is here is almost identical to this one. The functionality is identical as well. So all it does is create the constraints for this material and attaches all the attributes. It'll create all the glue constraint attribute, like the constraint name attribute, and all these attributes for you onto the fracture geometry. So that's what this does. This is like another option. If you, on top of the fracture material, you can lay this down on top if you have multiple constraints to create. So this only allows you to create a constraint for one constraint for this fracture. However, if you have multiple constraints that you want to create, maybe you want to select a certain group before putting the constraint on. So that's what this does. Just keep that in mind. I'll show an example a little bit later. The one that we really want right now, in order to fix this parallel breaking, it's not breaking very naturally, not the way that we expected, or not the way that we want. So metal should be tearing off. These pieces that are parallel, that they're sort of shifting out of place. It's not really breaking, tearing off is what we want, like a tear. Like we want this piece to rotate up here, all these pieces, so we would have a tear hole over here. We want RBD Convert Constraints. Now let's put this down. Oh, I should have. Okay. I'm gonna have to put a null here to visualize the constraints. Let's put it. No. Let's come here and let's visualize this. So this is our constraints. You know what? I might just use that after all. So let's pull this down. Constraint. I will use this constraint properties. We'll use it right now. So one good feature that this has that this RBD material fracture constraint tab does not have is that this, we can color it. So this makes it a lot easier to see. There you go. So the white is our geometry, the red is our constraints. So that's one good feature of this. We need this. I'm going to make it 1000. I'm just going to disable it here then. Now the way that the constraints are joined up right now, if we look carefully, the constraints are being joined up at the center of mass of each fractured piece. So the center of this piece is connected to the center of the nearby piece, and at the center of this nearby piece and this, and it does that like thus creating like a whole network that looks like this. What this will do, we can choose how to connect these, how to create this network of this constraint network. We can choose how. So I'm going to take this, and instead of using constraint type of center mass, I'm going to use surface points. Oh, and also for the constraint properties, we have to enable this back on too. That's just another thing. So it's giving us an error in the RBD Convert Constraints. That's because we need to put these two nodes before the RBD Configure. Some of the attributes in the RBD Configure is confusing these two nodes. So I'll show you. If I ignore this, the error goes away. I'm going to wiggle this out, or just cut it out. Move this up, hook it up here. So we're just going to play around with the order. In the RBD Convert Constraints, we changed the constraints from the center of mass to surface points. We have converted these constraints into the surface points now. I'm going to convert this to surface points. So now they're being held on the edges, which is something I want. This is what I want, because I want these pieces to be hanging on the edges when it breaks. So let's go here, and let me run it first, and I'll show you. This is what I want. So this is much better than the previous fracturing, how it was previously fracturing, because without this conversion, without this, it would be fracturing in parallel. All the pieces were kind of like sliding out of place. Now that the constraints are being held at the edges of each adjacent piece, it is rotating upon collision, and it breaks. It breaks in the proper way. I hope that makes sense. It's different from what it was before, is what I'm trying to say. Before, it was not breaking like this. It was sort of breaking in shifting piece mode. It wasn't really breaking. It was just shifting up and then shifting down, shifting out and then shifting in, because the constraints were held by the center of mass. And now that we've changed how the constraints are created, the structure of the constraints, we've changed it to the edges. So it's being held, it's being glued together with these points. These are the constraint bonding points. This is where the glue is being placed and no longer at the center of mass. And also, there was another thing that we did too. When the constraint breaks, we have checked switch constraint type when broken. So it's being shifted from a glue to a soft constraint. So it's being held together in some parts. Unfortunately, this wasn't held together with this. I kind of wanted this piece to stick here and then to stay in place. So this would end up like a tearing, like the ball tears through a hole through the metal. That's what I want. Now, in order to achieve that, the first thing is the stiffness. We have to increase the stiffness. Let's give this 1,000. Let's enable the plasticity so it stays in place. Not only that I want this glue to stay, I want it to stay in place as well. So enable the plasticity. Now let's see what happens. Okay, so we're getting that bump again. We're getting this. This is how I want it to stay in place. I want it to break and stay like this. Unfortunately, the soft glue, because it's already turned into a soft glue, is too strong. So it bounces back. Constraint here. So in the RBD Constraint Properties, we have increased the stiffness. So it's giving us an error in the RBD Convert Constraints. That's because we need to put these two nodes before the RBD Configure. Some of the attributes in the RBD Configure is confusing these two nodes. So I'll show you. If I ignore this, the error goes away. I'm going to wiggle this out, or just cut it out. Move this up, hook it up here. So we're just going to play around with the order. In the RBD Convert Constraints, we changed the constraints from the center of mass to surface points. We have converted these constraints into the surface points now. I'm going to convert this to surface points. So now they're being held on the edges, which is something I want. This is what I want, because I want these pieces to be hanging on the edges when it breaks. So let's go here, and let me run it first, and I'll show you. This is what I want. So this is much better than the previous fracturing, how it was previously fracturing, because without this conversion, without this, it would be fracturing in parallel. All the pieces were kind of like sliding out of place. Now that the constraints are being held at the edges of each adjacent piece, it is rotating upon collision, and it breaks. It breaks in the proper way. I hope that makes sense. It's different from what it was before, is what I'm trying to say. Before, it was not breaking like this. It was sort of breaking in shifting piece mode. It wasn't really breaking. It was just shifting up and then shifting down, shifting out and then shifting in, because the constraints were held by the center of mass. And now that we've changed how the constraints are created, the structure of the constraints, we've changed it to the edges. So it's being held, it's being glued together with these points. These are the constraint bonding points. This is where the glue is being placed and no longer at the center of mass. And also there was another thing that we did too. When the constraint break, we have checked switch constraint type when broken. So it's being shifted from a glue to a soft constraint. So it's being held together in some parts. Unfortunately, this wasn't held together with this. I kind of wanted this piece to stick here and then to stay in place. So this would end up like a tearing, like the ball tears through a hole through the metal. That's what I want. Now, in order to achieve that, the first thing is the stiffness. We have to increase the stiffness. Let's give this 1,000. Let's enable the plasticity so it stays in place. Not only that I want this glue to stay, I want it to stay in place as well. So enable the plasticity. Now let's see what happens. Okay, so we're getting that bump again. We're getting this. This is how I want it to stay in place. I want it to break and stay like this. Unfortunately, the soft glue, because it's already turned into a soft glue, is too strong. So it bounces back. Constraint here. So in the RBD Constraint Properties, we have increased the stiffness. So I don't need the control rest length. I don't think I need this. So this will use the rest length. That's the length between the distance between each fractured piece and its neighboring piece. And it's going to use that to determine the plasticity, how stiff it is, how much it's going to bend according to its neighboring point. Now I don't want to use that. I don't want to use the rest length to determine that. I want to override the angular stiffness and dampening ratio. Now this is something I need because these pieces they're bending already. Like this is what I want. This is the kind of form that I want, but I want it to stay. So we want to overwrite the angular stiffness. We want it to stay, the stiff to be more angular stiff, I guess. I'm going to check this. And then here we have, after checking enabling this, it opens up another UI here. Enable angular plasticity. That's what I want. Enable this. Okay, let's try it again. Now it's still it's not stiff enough. It feels like it's a balloon, a wormhole going through it and closing up really quickly. Angular hardening. Let's increase this. I don't know, 100. Now it's way too, it's too hard now. Okay, let's turn this down. It's way too hard. Let's try it again. So it's breaking off. It's still breaking off. Make the angular rate. This is how fast do you want the plasticity to stiffen up, sort of, to turn more plastic-like. Now I want this to be super high. I'm gonna make it 1,000,000. Okay, this is where the magic begins. Now this is this is the effect that I'm trying to get. This tearing effect. So this got us super close. Now this looks more starting to look like metal. Now we're not done yet. Getting us close. This is super close. There's another RBD node called RBD Deform Pieces. And let's try this. Let's put this down. Now what this node does, it takes all the pieces and all the nearby pieces and it joins them together according to a radius. Now right now it's not doing it properly. We need to tell Houdini where to join the pieces together in order to get that metal tearing effect. So let's just use constraints. The constraints works too. You can use cluster attribute if you wish. But I don't think we created clusters yet. So you can specifically design the way for the pieces to deform. That's where this attribute will come in handy. But we're not going to do anything complex like that. Let's just use constraints. So this will tell it how our metal plate or metal sheet was held together, how it was bonded together in order to help this node define where to weld these pieces. So what this node does, it's just welding pieces together. It's welding these cracks together. You get this one clean sheet. So that's what this is doing. Remember that the rest frame, this is what you need to feed in to tell it how it looks like before it was broken, like as a whole before it's broken. This is what it will use as a reference. So we want to tell it this is what it looks before it's broken, so it knows how it was broken and which pieces to be welded together. Now we can adjust some of the parameters to get rid of these holes. Let's make this smaller. Keep going. That's not helping. Let's go pieces number too much. I think that got rid of most of the holes. Minimum points. Let's go. Nope, that's not helping. I don't think that much. Proxy by attribute. I don't think it's finding the pieces correctly. Okay, parent piece. I'm gonna use name. Okay. I think it's too much now. Let's go back to 1. Ooh. So I'm just gonna play around with this. Okay, that got rid of a lot, except for that one piece. Some of the underlining faces are sticking to the top surface. Okay, that's a lot better. There we go. Feeding in the proxy name helped this RBD Deform Pieces node figure out which piece is close to which piece, and then increase the radius, the lookup radius, where to find the nearby point piece to join together. Increasing this radius help fill those little gaps. Now, if you want to render this out with RBD Tools, it's so easy now. We don't need a DOP import. This is ready for render right out, like right out of the box. So I'm just gonna do a quick render just to show you. I'm gonna turn this off. I'm gonna turn off the RBR because I want it to come out all at once. I need a light. I'm gonna set up a really simple light. Okay, so let's give this a try. Okay, the light is way too bright. Let's lower this. Background. I'm gonna adjust the light a little bit more. Okay, I'm gonna throw on a super simple material because we can't see we're losing some detail. Let's give it, I don't know, aluminum. Deform, render material. I'm gonna choose that aluminum. Oh, I didn't give it a name. Let's name this. Re-render it one more time. So this is not that great of an angle. Let's change the camera angle. Let's go like this or this. Okay, so we can see some of the tearing. I'm gonna turn up the sunlight. I'm gonna throw on a really simple HDR map. Let's see. Okay, that looks a lot better. I think we can lower this down. Maybe change the angle. This one. Okay, that looks a bit better. Okay, so this looks more like metal, like it's denting. So we can do this in different angles. I'm gonna choose a new camera. This camera 2, and I'm gonna one for the back side, so you can see what it looks on the back side. Oh, and the ball's not rendering because this sphere is a primitive. Change it to a polygon. Now the ball is white, so it's not showing up very great. I'm gonna give the ball a material. Oops. I'm gonna give the ball a plastic material. Plastic is this green. Come up here. Re-render this. Okay, there you go. This is just the beginning for the RBD tools. I can't wait to see what side effects we'll add to Houdini in the next release. When you think about the RBD tools and the Vellum nodes, I start to see a pattern that SideFX wants to put more of their nodes on the SOP level and avoid the whole .NET workflow. This makes a lot of sense to me because most newcomers to Houdini may get stuck on the .NET. I remember the first time I had my simulation set up inside the .NET, and the first thing I wanted to do was to render it out. But that turned out to be more tricky than I originally thought. Putting everything on the SOP level will make things a lot more intuitive for newcomers. However, there is a trade-off. The .NET workflow is actually very well designed because it creates a more compact and flexible scene setup. For simple scenes, I can see how the RBD tools would be more popular. But for larger and more complex scenes, I would prefer the .NET approach. Perhaps sidefx may surprise us with more improvements in the next release. Anything is possible. Thank you for watching and sticking to the end.